ながら行きました。動いてないらしいですから、向こう方面動いてないって言ってる。この辺。
Good morning to you all. So, you came to probably one of the least technical talks that will be given this week at Ubicon, I guess. Or, I guess. So who am I? My name is Patrice. People call me Patrice in English all the time for some reason. As you can see, there are a number of kids, animals. We have 28 cats at all these days. But I'm mostly here because I've been teaching for 22 years now. This is my 22nd year, in fact. Particularly there. So I teach both at college level and at university level where I come from. And you have to know that in Quebec, college comes before university. It's not the same thing. There are different levels. People go from high school after 5 years to college for 2 or 3 years and then move on to university should they be so inclined. So, this is pretty much what you can see right now on the picture. There are some beliefs with respect to C++ as a first language. As C++ has a bad reputation. Well, yeah, which might be appropriate or not. I haven't really think about that. I've heard many things. It's a difficult language to learn. There are so many things in there. It's complicated. It's inappropriate when you're starting. It's messy because it comes from another language. It's not really object-oriented. It's expert-friendly, which we hear quite often, which could be true to some extent. I've had a number of discussions on that topic this week. Yesterday, I was taking a walk with a student after totally agreed that it's an inappropriate language for beginners. I asked him why. Well, I said, don't pay teachers enough. What's the relationship? Well, it's complicated, so if you don't pay teachers enough, well, you won't get anyone good to give classes in that language, but isn't that true for any language? So, yeah, kind of. I was talking this morning again with someone else from some company who told me, well, it's the difficult thing is the memory management. Well, I don't do that with beginners. Right? Anyway, so these are points of reputation that we have in C++. And then the most painful point to me today, the reason for this talk is the one that you see both writers right now. Is it inappropriate for beginners? Yeah, I understand it. This worries me because I've been giving C++ classes to beginners for 21 years in Canada, so I'm wondering if I did something wrong. So how will I proceed today? I took the first few exercises I'm giving to beginners normally. Very, very simple stuff, as you can see, so it's not technical. The worst I will do today is write a function. I'm really sorry for the noise that it makes. I'll write solutions in many languages already. I'll use Pseudocode because I use Pseudocode at work. I hope you won't mind. I'll use Python. I learned Python this week writing these examples. Because people told me it's easy, so I said, well, I'll try to learn. I must say it's been enlightening to use Python this week. If it's simple, it's like most languages, it's simple when you know what you're talking about. I wrote it in C++, of course, Java, C#, I'm proficient in all of them, that's okay. And I'll go through them with you, and well, maybe they will change your mind if one of them is really more appropriate than the others for beginners. So that's what I'm going to be doing. You have to know that my students, so those I have in mind right now, they are 17 to 20, so they're fresh out from high school. Most of them. I have some experienced ones, but I'm not talking about the university people that I get because those are prior programming experience. That's not what I have in mind. They have what we call high school plus 2 months because they just graduated, so they're nervous coming into the big world with higher education and everything, so there's a lot of new stuff for them. But we don't suppose that they have learned programming beforehand, so they come with a fresh start. Some of them, of course, have. And these, well, we have to give them more structure because they know what an if statement is and what a loop is. They know what a type is. Yeah. So, and most of the programs that I'll be using, I've been there for a while, so I just don't want you to think that they are biased towards C++ or anything. I went through the same essential problems when I was a student because I went to the same school in the 1980s in Baskin. Okay, so it's the issue is not the language, it's what people to get. So as I said, I'm going to use many languages for each of them. A few words of warning, because we're in a world experts and conference of experts, so you will see things you will not like in the code, but you have to take the beginner's perspective in this case. So I will be using braces sometimes in places where I wouldn't use braces in real programs, but I'm giving beginners, they don't know what a scope is, and they're nervous. I have tried to respect the brace style of C# because they have imposed style practices for C++ syntax, so we won't go too much. I know that people these days don't use only uppercase symbols for constants. I will, because there's pseudocode in there, and when students begin, they don't really know what a constant is, they're lost a bit, and it's a visual marker for them. So when I start, that's what I do. You don't have to maintain that, and in C++ we use uppercase stuff for macros. That's not the idea here, it's French language. You will also see things that I've never done in real life, which means declaring a variable and then writing to it later on. But again, when you're doing pseudocode, when you're mixing declaration and initialization, you have to forget to do one or the other when you're writing real code. So just to keep things simple, it's not production code. Okay? Everyone is agreeing with this. It avoids weird mistakes. If you don't believe me, well, come to my other side next week. Whereas if I was doing C++ code, I would be clearing the thing at some point. I would never declare that initialize. But again, bigger code, and we want them to be able to translate from one scheme of thought to the others. That's the point here. Okay. It's not production code. Other things, using floats. Why? Because the word double doesn't mean much to students coming out from high school. Float is a bit closer to home, but a tiny bit. And that leads to interesting things because our natural floating point literals are doubles. You have to put suffixes to get floats. So there's the idea of types introduced there that takes some effort. So that brings the effort in, and it brings mistakes, and you have to think about it. So you'll see that in the code. And things that such as the fact that if you do 4 divided by 3, with most programming languages that we use, not all of them, you get 1 that's integral division. It's surprising to students who've done physics and maths using a calculator for 5 years and have forgotten that integral division actually exists. So it's fun. Okay. So don't worry about it. It's deliberate. It's not to make languages look bad. That's what I mean. And you will notice that there is no error management. I'm not making sure that the inputs have worked or anything because when you're starting to work, you have other things to worry about. So if there's big thing in it, and there's ring mama, and it crashes, when it crashes, we start over again. That we don't hear. Okay. So I don't do LOL in class. To be honest with you, I don't do that. I brought this in just to start things up, and because we forget what these pieces are when we start. So I think that this doesn't need explanations for you, and it probably makes sense to students beginning to do encoding. And if you look at the thing there, there's a number of things. I use print. So I entered a word there that if I did that in class, well, we'll use that word. It's special for us. It's a primitive. We'll take into account or take for granted that this does something specific. You can use other words for that. That's the word that we use. There are rows. That's really fun because play with beginners, they wonder why you use double quotes or not 2 single quotes or just single quote. Why not? It's not the same thing for us in most languages, not all of them. We in C++ make a distinction between one char and many chars. And that's not a question they probably have ever asked themselves. So that's actually interesting. So there's information hidden in such a simple thing there. And if you look at the C++ version there, well, there's a lot more noise. There's a lot more noise. But that's okay, because we're starting to think. We are going to learn. So there's this include thing that we will use import for at some point, but not yet. So there's using there that I'm going to be using as magic, just like I would do in C# with using system or in Java with import Java.io with star or something. We do some magic when we begin with people that have never programmed before because there's so much to take in. We forget. And there's this int main thing that you can start explaining this right away. You don't even know what an int is. You don't even know what the type is. There's randomized. And the brace thing, our neighbor units say, well, it's magic. I think to me, the word is always include the braces. So that's what we're going to be doing for a few time, for a few weeks or something. And there's this thing now, see out that equal, okay, print, see out. I'm guessing there's a reason. And these like bracket things, but they can press that. But there's the syntax there to get along with. So it seems so evident to us that we just don't think about it. But these are the that we have to think about. Is that easy? Is it easier in other languages? Well, this is C#. I don't know if you noticed, but there's noise on the screen too. There's noise in every language, even in Python. Look at this. There's all of these lines. There's 2 levels of braces there just to start anything. You can't do anything without them. There's this class program thing. There's namespace thing that they have to put. They don't have much of a choice. That's using thing. That's magic. That's okay. But we accept magic in most languages when we start. Before we explain things, but it's not simple. There's noise. There's noise. And there's a lot of words on that main thing there. They don't need to put the string bracket there, but when they generate code, they will end up with that, and they will wonder what it's there for. Static, void, main. There are lots of words. And you tell them, well, it doesn't matter. It's noise. It will be generated for you by your tool, and you'll be writing between those spaces. But put your stuff there. Don't put it at the left. That's for you, because it means something to me. And I'll get back to you at some point. Indentation is way too early to think about that. And there's this thing there, console.writeline, yeah, print. There's a they take it in, that's okay. But there's noise, so there's things to take in. It's similar with Java. Well, think about it. Lots of words there too. So it's like I think there's that class thing there, there's braces, there's positions, there's a lot of words in the first line there. And there's this print thing, there's many words to print, they might complain, but they can press that, that's not a problem. But there's still syntax to bring in. If you ask them to print that by themselves, they'll make mistakes, of course, there's too much. But it's okay. It's worth it. Lots of words. So regardless of language, there's syntax. It's fun, it's exciting, it's hard to take in first. And yeah, and there's this function like syntax with parentheses that we use with C out and CN, we use those angle bracket things. Some people might think it's more difficult, but think about it, they've only seen functions in the mathematical sense before getting to computer science. So to them, y equals f of x. It means that the 2 things have the same sense, not that there's processing and assignment. Assignment is, they've never done that before. It's new stuff for them. So it's fun, it's weird. And it's try and reading, but I don't start with this, it's too easy. My software is something like this. I tried to make some basic maths with them because they've just done some physics and some maths in the last few years, so it's closer to them. So I told them, I said, oh, you're in college, you're big, the guy, the girl, and then you go back to high school to see your friends, and you meet your physics teacher getting famous for remembering things, and wants help in implementing something that will compute the volume of a sphere or something, because the formula is getting difficult to remember. So they have to think about it, they discuss with the person, try to figure out what's the ins and the outs of the formula, and they have to work it out. So they need to get to the recipe of the algorithm where they get from input to the output and try to do things in the right order. It's very simple, it's 4 steps. But it's the first time they've ever done such thing. So the closest that they have to that is driving directions maybe, or doing a recipe. If you don't do things in the same order or right order, sometimes you get very weird results. And there's this IO thing that's not simple there. So just expressing the algorithm into the code, it's a challenge. Because it's fun. It's not just words. That's the paper first time. You can do that. I don't get in the room right now. So if I think with use debuggers, super early, and I do that. I use debuggers early, but I don't use debuggers first. I wanted to think it. So just testing hypothesis, I'm thinking, well, if I put one there, what do I expect to see coming out before I start running actual tests? What's my plan? So there's this thing there also. Like I'm going to try to compute the multi-orbit. But I'm expecting to get that output, and they work a bit with the calculator and everything, and move forward at 18 or something. I have a plan. So consider is inverse, so you have something like this, like a constant upfront I. That of course it's worth 3, 14, 15, 9. Everyone knows that. Kind of. This is kind of a joke. They read the radius, so there's a word there to learn. And then there's this weird computation there where deliberately there's the order of operations to be aware of. So there's the exponent thing, there's the division, a couple of multiplies there, and there's the assignment that's totally new for them. So something going on. So yes, you do the right hand thing, and then you take your results and to the left side. You have to make the noise. No noise counts. Especially when you're writing functions, things move about. And then you print the output. And there's an ordering to that. So you go through that, and yes, if you don't do things the right order, well, it won't work. Because if you don't read the radius first, you get used to it in an operation afterwards. It's kind of new, it's kind of brilliant. But it makes sense. I don't get complaints from that. It makes sense. So they move their head like this up and down. Yeah, okay, yes, of course they don't get it because they haven't done it, but still. So you look at this, there's a lot of information. So you have the primitives, read, print, and the assignment. The assignment is complex. There's a symbol, the constant. There are literals in there. There's input and output, which is really not simple for people. I'll return back to that later. I have rules for names. I impose rules, like variables are like this and constants are like this in my class because you're starting and I want to know that you're getting what you're doing. There's a number of arithmetic operations in there. It's simple stuff. Assignment, and do not underestimate the problem of doing things in sequence. It's surprisingly difficult for beginners. They tend to skip over operations. Because in that math, in high school, they skip operations because they're so bright. But of course, if you do that with a program, well, you get the result that you deserve. And Python is not that far. This is no, I cheated. Before, if there are any Python experts in the room, I know that this one cheats. Because it didn't fit in the slide. Okay. But that's pretty similar to pseudocode. So those who say Python is like pseudocode, well, so far so good. Except that it's not as simple as it looks. So when I was trying to write that, I wasn't playing. I said, okay, I'm reading input radius, I get that. I would put it in the variable, then use it, and it crashed at runtime. I was trying to use my radius and it crashed. And this made me think, people complain about our error messages, but they should be using Python to discover the pain of error messages that say nothing. It just doesn't work, it doesn't tell you why, that's awesome. You get a string and it tells you it could be a no something, a no type, I think, or something like that. Because you read something but you didn't cast it. So you actually need to, if you do input in Python, you need to learn casting first. But you don't know what a type is yet. So we underestimate these things. So, of course, for us, it's not difficult. It took me a minute to find out, but still. So it's not simple as it looks. But apart from that input thing, the rest is pretty much that's self-explanatory. I think if you get this code, you get this. And yeah, that's what I just said. The static typing and static error messages are pretty nice. When you don't have them, you realize how much you miss them. And our error messages are much better in C++. You can test that now. Now, if you look at C++, you say, okay, well, this is much more noisy, and you want to correct. You're absolutely right, but this is noisy in general anyway. There's also that one, but it isn't, because that's what you get from the idea to real life. So first, there's this literal there that has an F at the end. For a student, that's surprising. Why would I have to say something like that? Well, I tell them you have balls are big, and your plants that are small. If you want to put a big number to a small box, you have to shut good enough. That's natural, but there will be blood all over the place, no work. And I'm using float deliberately again because the ball doesn't say anything to them. Float kind of has meaning, so it's okay. But I declare before I use, as I said, I'm going to do that in real life for the variables. And there's the types thing. But why would I need to say that it's a float? Well, your computer doesn't know if you're talking about text or integral or floats. They've only been using floats all of their lives. They have no idea what these things mean. It's all new to them. In fact, they used to do that in elementary school, but they forgot. And they didn't text to them. And these are these semicolons and commas there that are weird to them. So why should I need to do that? Well, you know, it's not line-based, it's token-based. So you're going forward, and until we reach the semicolon thing, the punctuation, we don't know if you're done telling us something. Forget that. So that F thing, I don't put that first. The thing I did with that, I made it like pseudocode. And then we get this word warning in C++, it's an error in Java and C#, and so this warning, normally. And that's why it's complaining. So you know what, the weird thing I do with them, we read the message. We actually read what the compiler tells us. It's really cool. Because they check it out with 17-year-olds, they don't read. They skip words. It's every year, it's awesome. So they read, and they read just some words, no, you read too fast. Let's take it one word at a time. It actually makes sense. The messages we give them make sense. It's cool. And it actually tells you to put the F at the end if you really want it. So we put the F and it works, it's like awesome discovery. But that's the fight of the entire semester, reading the damn messages. I swear it's the most difficult thing you have to do, but programming it's really okay. It's not because they're bad people. It's because they're right people, too fast. So do not risk them. And then there's a number of things there. If you do 4 divided by 3 in C++, you get integral division, so you get 1. That's deliberate. I did it on purpose. So I first type the things as we did in pseudocode, and then at some point we make it compile, and then we run the thing. And then we enter 1 as radius, and we expect to see 4.8 something, and we get pi. And there's like silence. And some people are saying that the computer's wrong, of course, because the calculator does not what they get. So it's wrong, sorry, the computer's right. So you discuss types, teaches the ID with them, integral division, makes sense to them. 4 divided by 3 means 1. And then you do it for them, 4.0f or something, and they see that the numbers change, it's like regulation, there's a shock. Because you have to be precise, you have to be more rigorous. That's part of the learning process, of course.
Okay.
So yes, it's interesting to do with them because there's a shock there and there's something to get from. And the fact that you have a nice thesis if you're under code and then validate it is already enlightening in itself. But that's C++, see? That's cool. equal sign, because equal means something different to them. That's weird. That's weird. But they can get through that. And that EMDL thing to change lines, the fact that you would want to do something special to change lines, that's not evident, something of the other. So, but that's just syntax. So in C#, it's pretty much the same noise, don't you think? The biggest difference there is that there's a new space, and please let me tell you, I used an accent there, it's deliberate. I'm French, as you can tell from the accent. So are most of my students. And the fact that they cannot use accents in their symbols in C++ is a bit of a pain, to be honest. They would rather be able to write in their own language. It's not bad, but it is an obstacle to appreciating the language or something. So there. But it's the same thing there. The big difference between the constant in both languages is that you get a warning in C++ and you get an error in C#. But you get to the same point, there's something on screen, you read the message, it's pretty clear. So I don't think it's bigger or smaller, it's kind of a little difficult. I'm not sure the beginner grasps the difference between a warning and an error. Anyway. And again, I do the same dance. I start without F, get the error, read. I do the same dance with the integral division with the floats, get some results. So input and output are a bit more complicated. And you would have to think that the job is easy because it's flow.bar stuff console.readline with two levels of parentheses. There's text involved, an actual transformation to flow that you have to explicit in there. It's actually simple. For beginners, I think. We kind of, I go as far as saying we do it a bit better in C++ for beginners. Beginners, it's not something it's around. And console of right line, it's not so difficult. So there's a transition between your mind. But is it more easy, more difficult? No. And if you go to Java, it's a bit more complex. Java, it's not beginner friendly because of input. If you've never written Java, reading from the keyboard, it's spectacularly difficult. But it's stage one for beginners. I mean, you want to do your name, hey, you, or something. So look at this. Same thing, there's silence, there's const, that's not bad. Same thing, procedure with the float and everything. Same thing, issues, same division issues. That's all interesting. You can teach that in the language as well. But now reading float, the big F, that parse floats, you have to read the float for some reason. And you have to create something to actually read from the input. There's nothing set there. It's very difficult. It's like another recipe to learn. Nothing insurmountable. You can write library to do that for you. But then you would have to use library in your code. It's short to do it. It's not standard, so they would have to unlearn it at some point. And there's a big float with a big F and a small float. They are two very different concepts in Java, so you have to be careful. And probably not show it right away because you got to drown them. So yeah. Is it a better language to begin with? No, I don't know. And then you have to use try and catch because there's no way you can do it in Java without managing exceptions. You're not even allowed to. So you have to do something. You don't have to explain it, but you have to take this into account. So it's a big recipe to do something very simple. Yeah, that's fine. But at any times, it can definitely be done. Nothing in there is an obstacle to learning programming. Okay. And another thing in there is that none of these three languages has an actual exponent operator for good reasons. So when they're moving from code to code, well, they have to do something. So we can bring it to actually equal function. Now there's something subtle because they're used to saying y equals f of x is y and f of x mean the same thing. But now we're saying, no, f of x does something, returns something, you store it in the variables, something completely different in terms of concept. But they get it, but it's not immediate. It's the same thing in all languages. So if you look at C++ there, where we're calling only is very loud, but we're talking about because I don't speak German. And you include CMAP, but that's something people can deal with. Including library, calling it's okay. Now, looking at C#, it's pretty much the same thing, except for one little detail. We have overloads for the math functions in C++. You can count out what's written in the float and you won't get to do extra work. In C#, they're all returning doubles, so you need to learn casting to do that. I think that's something more to learn. Oh, okay. It's not that WP because so same thing. And in Java, you end up with the same result. You have to cast because the function all return doubles. Nothing to that, but to cast. When it's the first time you need to type in your life and you just learn float. Okay, also let's take it. Just practice. But, yeah. So simpler, I don't know. Simpler. So you want to call them mathematical functions at some point because they're going to do maths because it's closer to them than text when they come from school. You know, they come from high school, they've done maths, but manipulating text is something they're going to learn with us. So realistically speaking, they've done some minor algebra. So what I do with them is I take the Pythagorean theorem with the hypotenuse and everything, but I make them read the hypotenuse and one of the hypotenuse and the computer rest. So they have to do something very similar. They begin it with a problem. So the code gets something like this. As you can see, there's a square root thing there. Square root and two power things. Power is easy with pseudocode, it's an operator. Square root, they wonder about the syntax, they want to do this little beautiful mathematical symbol there, and the well, most of the code use the keyboard, so don't do that. So nothing difficult there, Python. Well, you import math. You have to cast your inputs to float, so you have to learn casting. But if you look at the equation, it's pretty straightforward, given that you actually got a number in the first place. So that's fair. If you look at C++, there's more noise again, but really, the real thing is you need the math thing that you've already seen, maybe. And you do your square root there, well, it's functions, it's pretty straightforward, and there's no casting involved, so it's not that bad. It's reasonable. Oops. Now I'm moving to C#. As you can see, it's smaller on screen. Why it's smaller is because all of the braces, the usage is to put them in a vertical manner, so with strings it's not useful because you can grab more information on the screen, so you have to split it up like that. So, but the difficulties are pretty much the same. So you need your variables, and one thing I didn't mention is that this problem, since you're reading two of the three sides of the triangle, you're trying to deduce the third, and that third one is neither an input nor an output, which is weird to students sometimes, because they want to, what they're doing is not an input but an output. Should I read it? No, you have to compute it. There's something to do. There's an intuition there. That intuition I don't really get when I write swap with them. And the reason I put swap as an example because it's literally easy, because you cannot write swap in Java because there's only by value, which is crazy. So there, that being able to write swap is scary. So we have this additional variable to put in all languages, and when you're computing this thing, I don't know if you can read that of math and square roots, of math that farm something. There's like 3 or 4 levels of math there, plus a cast. It's really not a simple equation. It's interesting, but there's a lot that they can, and when they do it by themselves, it takes a few times before they get it right. Just casting in the right place is difficult. But they have to do that in skate because the variable is float and all the functions return doubles. So you can make things simpler by making doubles all over the place, but it wouldn't be learned. If you're a teacher, that's a bit of an annoyance. And if you look at Java there, it looks worse, but it's because of the inputs that are terrible. Because the actual mathematical part is the same, so that's not a problem. So, yes, it's not that bad of a language for beginners. With these examples, I